And last class, where did we stop? I guess we stopped at finishing.
So LCF not at mistake, the topic.
Yeah, we finished two problems, one with LCF at midship and next one was LCF not at midship. Okay. So now we will start off with a new topic, effect of loading and discharging of weights. So effect of loading and discharging weights. Now till now what we have seen is like we have seen a weight which is being shifted forward or aft. The weight is already on board and we saw how the change of trim occurs, and with respect to LCA position how it affects the trim also. So till now we did not talk about loading and discharging of weights. So when you are loading and discharging of weights, let's discuss how it affects the vessel and how does the trim change. Okay. So if the weights are loaded or discharged, the effect of bodily sinkage or rise must also be considered. Okay. Sinkage, the formula for sinkage or rise in centimeters is small w by TPC. Okay, so just you have to note down this formula, sinkage or rise is equal to W by TPC. The following procedure should be followed when loading a weight. Okay, so how is it different from shifting of weights? Okay, now let's take now an example where shifting of weights. Now, when you are loading the weight at the LCF position, first calculate the sinkage using TPC value. Okay, if you are loading at the LCF position, the vessel will sink uniformly. It doesn't have to be anywhere else. Now let's take this example itself. This is your aft perpendicular and forward perpendicular, and this is your midship. Okay. Now till now we have been seeing only shifting of weights. Now this is my F position. Okay, this is my F position, and I'm loading exactly at F. Okay. So if I am loading exactly at F, the vessel will bodily sink. Vessel will bodily sink means my forward and aft draft will go down equally. Supposing my sinkage is, let's say, 10 centimeters, my forward draft will go 10 centimeters, my aft draft will go 10 centimeters. So that is when you're exactly loading at your F position of F, because your LCA position is the deciding factor how the vessel will trim. But if you're loading exactly at F, your vessel will only have a bodily sinkage. But if we load anywhere aft of F or let's say forward of F, it need not be, it can be anywhere from F to aft perpendicular and from F to forward perpendicular. Anywhere if you load forward and aft of F, you will have two factors. One is you will have a bodily sinkage because you're loading a vessel. Sinkage or rise, it can be anything. Sinkage or rise due to loading or discharging of weights. And you will also have a trim change. When you load at exactly F, you will have only sinkage, you will not have a trim change. But when you load either aft of F or forward of F, you will have you will have both sinkage or rise and change of trim also. So we will see both those factors in a problem. Okay, so sinkage or rise can be given by W by TPC. W is the weight which is being loaded. So when I tell you like this is let's say F, okay, and this is my position F. When I load a weight here exactly at F, let's say my forward draft is 5 meters and my aft draft is 6 meters. Okay, so I've told you when you're loading exactly at F, you will have a bodily sinkage. Bodily sinkage, how will you find out? You will find out with this formula, W by TPC. When W by TPC is given, you can find out the sinkage or rise of the vessel. Sinkage when you're loading, rise when you're discharging. So let's take an example. In this case, we are loading, so the vessel will sink. and W by TPC will give you how much it will sink. So let's take in our case, let's say it sank by 10 centimeters. Okay. So what would be my final draft? My sinkage is bodily sinkage. My bodily sinkage is 10 centimeters. And I have loaded the weight exactly at F. So what would be my final drafts? You're there?
No change, sir. It will be go down.
Sorry?
Bodily sinkage, sir.
So just tell me, bodily sinkage means what will be my final forward and aft drafts?
It will increase in both 10 centimeters, sir.
Yeah, okay, exactly. Good. So my forward draft will become 5.10 and my aft draft will become 6.10 because we are loading a weight and we are loading a weight exactly at the F position. So I will have a bodily sinkage. So at both forward and aft, it means that my entire ship is going down by 10 centimeters. So obviously my forward and aft draft will increase by 10 centimeters. Now this is a straightforward case. The case when we'll have a changes is when you're loading something aft. When you're loading something aft of F or something forward of F. In that case, what will happen is you will have to find out sinkage because there will be also sinkage and there will be a trim change also depending on where you're loading and the distance where you're loading from the F position. So let's see that how to go about that. Okay, so the following procedure we'll be following. We'll be first seeing where is the LCF position. Okay, we have to first find out the sinkage of the vessel. Sinkage we will find out with this formula. Calculate the change of trim by moving the weights from the LCF position to its actual loaded position. So first we will assume as if that weight is loaded at LCF. We will find out sinkage using this formula. Then from the actual position where it is being loaded or discharged, we will see the distance to the LCF position. With that, we will find out the change of trim. Then we will apply fine TA and TF correction and get the final drafts. Okay. The only difference between after finding out sinkage, find out the value of D, there is one difference here. Till now, your value of D was always the distance this. Because till now you have been only shifting weights from forward to aft means whatever the weight, whatever the distance it was shifted, this used to be your D. And it used to be directly given in the question itself that so many distance it was shifted from aft to forward or forward to aft. But here in this case, during loading and discharging of weights, D will be slightly different. It will be actually, supposing this is a weight which I have loaded here, and let's say my LBP of my vessel is 100 meters. Okay, and this is my midship at 50, and let's say my F is at 40. Okay, and I have loaded a weight here. Okay, now when I load a weight here, let's say my from aft perpendicular, this weight is let's say at 10 meters. Okay, now D in our case when we are loading or discharging is from the LCF position to the weight, to the LCG of the weight, that is this distance from here to here, from F to the
30.
point. How much?
30.
Yeah, 30, exactly, good. So from F to the point 10. So this will be my D, which will be 30. Okay, so that is the difference between when you're shifting of weights or loading or discharging of weights. Loading or discharging of weights, your D will be from the point F where it is to the point of weight where it is being loaded. Okay, so let's do a problem and understand it. Fine. Let's take a vessel ship of 100 meters in length. Okay. Initial draft is given forward 7 meters and aft 6.80 meters. Now calculate the final drafts. If 150 tons is your small w, is loaded. Okay. Is loaded 20 meters forward of aft perpendicular. Now, if I take this example, LBP is given to me as 100. So my midship will be somewhere 50. Okay. 150 tons is loaded 20 meters FOAP, means from aft perpendicular it is loaded at this point. And the distance is 20 meters. At this point, I have loaded a weight. TPC is given to me. MCTC is given to me. And LCF is 45 meters FOAP. Means from aft perpendicular, my LCF, let's say somewhere here, is 45 meters. Okay. So now, as I said, what will be my D? It will be exactly from F to the position of weight to this. So how much will be D?
25.
Yeah, 45. Yeah, 45 meters from the entire length, you take away this. So it will be from F to this position. So it will be 25 meters. My D will be 25. Okay, so just remember in this loading and discharging problems, D will be the distance from the center of flotation point to the point where the weight is being loaded. Okay, so first thing, we already know that since we are loading a weight, we will have a bodily sinkage and a change of trim also, because we are not loading at F. We are loading somewhere aft of F. If you load anything aft of F or forward of F, you will have two factors, one bodily sinkage and change of trim as well. So we need to find first bodily sinkage. So sinkage formula we know, W by TPC. Now why is it sinkage I have written here, not rise?
Loading.
Loading.
Because we loading, sir.
Yeah, fine. So since we are loading 150 tons, I'm writing it as sinkage. If you're discharging, you write it as rise. So W by TPZ 150 by 15 will give you 10 centimeters. So this is your bodily sinkage. Means your entire ship will go down by 10 centimeters. That means in this case, if initial draft is 7 and 6.8, it will become 7.1 and 6.9. So then what you're going to do, then you're going to find how the trim is going to affect, how the trim changes. Now for finding the calculating the change of trim, we need to find the distance D, which we already seen. D is the distance that the weight is loaded from LCF position. That is from already we have seen. From F, what is where it is being loaded, that distance we already found out to be 25 meters. Now for all these problems, I suggest I want you to draw sketches. Sketches is mandatory. Okay, then only you will understand where the weights is being placed, how the distance are there. Okay. So drawing sketch for all these problems is mandatory. So W is 150 tons into D, 45 minus 20 by 150. So which will give me 25 centimeters. Now rest, it will be the same as we did in the other sections. Since my LCF is not at midship, I will be using the formula for calculating TA and TF. Now what is the formula for TA and TF? You remember TA is A by LBP into COT and TF is F by LBP into COT. I hope all of you got my PPT right.
Yes, sir.
Okay, fine. So what is A in this?
$45, sir.
Yeah. As you know, A is actually equal to LCF. So LCF value is given to us as 45. So 45 by 100 into 25 will give you 11.3 centimeters. Okay, so you have found out the correction for the aft. Now for finding out the forward correction, either you can use this formula or you can slightly improvise it and just subtract it from the whole change of trim. Because I know my whole change of trim is 25. If my aft correction is 11 centimeters, 11.3, my forward correction must be remaining part, right? 25 minus 11.3, that will go for the forward section. So I can directly use trim forward is equal to change of trim minus trim aft, which is 25 minus 11.3. If you want, you can use that formula also, or you can just straight away subtract it from the change of trim to get the remaining correction for the forward section. So now I got my corrections, 11.3 and 13.7. Okay, now here once I find the correction, now I need to know whether to add or subtract to the forward and aft drafts, right? How will you do that?
Loading of the half, sir. So aft will be increased and forward will be decreased.
Aft will be increased and forward will be decreased. Okay, fine. Since you said loading at the aft section, now let me ask you, like, this is your midship, right? Supposing I am loading a weight here, what will happen? The vessel will trim by.
It will uniformly sink, sir.
No, I am not loading at midship. I am loading somewhere close to midship or behind midship. Will it go by stern or will it go by head?
It will be go by head, sir, because it is forward of F.
Okay, very good. So that is what I wanted you to understand. That is because F we already know is the pivot point by which the ship will trim. Okay. So if this is your pivot point by which the ship will trim, anything which you load aft of F, okay, you will have a stern trim increasing. Anything you load forward of F, you will have a forward trim increasing. Your forward draft increasing, here your aft draft increasing. So your F is the pivot point. So remember, anything forward or anything aft. Vice versa, even for discharging, it will be the other point. Supposing you're discharging anything from aft of F, you will have a head trim. Okay, so F becomes your reference point when you're loading or discharging. F decides whether it will go by head or by stern. In this case, what is it telling? That weight is loaded aft of LCF. Right, we loaded a weight at this point, which is aft of LCF. So definitely your aft draft is going to increase and your forward draft is going to decrease. So what we will do, we will take the initial drafts, apply the sinkage, which is 10 centimeter. You will be adding because you have loaded a weight. You will get your final drafts, and then you will apply this correction. So since LCF, you have loaded aft of LCF, aft you will add, and forward you will subtract. So you will get your final trims forward and aft. Understood on this problem?
Yes, sir.
Yes, sir.
Okay, fine. Fine. Let's do one more problem in this where you will be discharging weights. Okay, so that we will have much better understanding. Okay, a ship with LBP 160 meters floats at a draft of 3.22 and aft is 3.10. Now calculate the final drafts if 208 tons is discharged from a position. So 208 tons will become your W, is discharged from a position 118 meters F4AP, forward of aft perpendicular. Means from aft perpendicular, this distance. This red line means it is 118 meters up to this. So this is where your weight is being discharged at this point. Now TPC is given to you and MCTC is given to you. LCF is 88 meters FOAP. Okay, so my LBP is 160. Okay, there is actually a small mistake in this problem. What is it? Can somebody tell me? In this sketch.
LB,
Sorry?
What, sir?
Now there is a small mistake in this sketch which I have drawn, which I did not realize. I just realized it in the last class, which I have to correct it. But can you point out what is a mistake in this sketch which I have drawn? My LBP is 160 meters. My LCF is 88 meters.
It will be the forward of F will be in forward, sir. It will not be on the.
Yeah, exactly. Very good. Others, you're able to make out?
Because it's 88 and
Question.
yes, LBB is 160.
Yeah, okay. So that is the mistake. LBP is 160. So my midship is 80. So it means my
So
F,
it will be 8 meter.
yeah,
Forward, sir.
8 meters forward of midship. So it must, yeah, it must be somewhere here. So my F has to be somewhere here. Okay, here I by mistakenly I have put aft. So my 88 meters will be actually up to here. Okay. But it is not going to affect when you're doing a numerical, but it will affect your logical thinking and your sketch will be wrong. So it will give you a impression that you did not understand the topic. Okay, so don't make this mistake of drawing F. Because why it will not affect your numerical?
Not including that, sir.
Yeah, we're not including that means actually now this is 88 meters and your D position is 118 meters. So what is your small d actually? It
Sir,
is
108 or 200, sir?
118, 118.
100 minus 80, 20, 30.
So it will be actually this distance, right? From 118 to 88, right?
Yes, sir. It will be around
30,
30, sir.
30.
30, sir.
30 meters.
Yes, sir.
Fine. So that is your D, because anyway, whether if you marked it wrongly also, you're just going to take the distance from here to here. Okay, but it won't be a logical thing. So correct it actually. Now the distance D will be actually from this point to this point, because 118 minus 88. Okay, so that will be your position of D. So remember, always it is from your F to the position where it is being loaded. Now don't get into the impression of whether it should be a positive value or a negative value. No, nothing like that. It is basically the distance from F to the point where the weight is being loaded. That's all. So don't include a positive value or negative value as a prefix. Okay, so here we will, is it a rise or sinkage here?
Rise, sir.
Rise, because we are discharging.
Discharging.
Yeah, okay, fine. So it will be W by TPC. So 208 by 32 will give you 6.5 centimeters. So this is how my vessel will be rise, 6.5 centimeters. It will evenly rise. Now next what we have to find out is calculate the change of trim. Okay, change of trim is, we need to find out the value of D. D is the distance that the weight is discharged from the LCF. Okay. So here in this case, from the LCF position to the point D. So that will give my 118 minus 88. If you apply it in the change of trim formula, W into D by MCTC. So that will give you 20.4 centimeters. Now trim aft, we know A by LBP into change of trim. What is A in this?
88, sir.
Yeah, A is actually your LCF value equal to 88. So 88 by 116 to 20 will give you 11.2 centimeters. So this is my aft correction. If I subtract it from my change of trim, it will give me my forward correction. Forward correction is equal to change of trim minus trim aft will give me my forward correction. Okay. So now tell me, like, now I have my initial drafts. I found out the sinkage. Okay. Then I got the sinkage drafts. Now I got the corrections. Now the corrections has to be added or subtracted. Same like last thing you told me, right? With respect to F position, what are you doing? Or how is the weight acting?
Weight is at the forward of the F, sir.
Yeah, fine, good.
So, so forward will be
Forward draft.
will be rise, sir.
Right,
Will
sir.
be rise, sir.
Forward will,
Draft will sink, sir.
Forward rise.
just can you repeat it somebody with slowly? Weight.
Forward will rise, sir, because we are discharging the weight.
Yeah, exactly. Maybe initially you said the other way. Okay,
No, sir, this only. Forward will be increased.
fine. Forward will be increase means what, man?
Draft will.
That means rise. Rise. The
Yes, sir.
sentence is mistake, sir.
Increase and rise are two different things, man. Okay, increasing
Sir,
means
forward draft will
Sorry.
decrease, sir. Forward draft will decrease, sir.
okay, fine. So here your draft is not increasing, it is decreasing. Okay, so you say either decreasing or rise, or your vessel is rising. Fine, good. So we know that my F position is somewhere here and a weight is being discharged from forward of the F position. So when you are discharging something forward of the F position, my forward draft will decrease. Okay, and my aft draft will increase. So the correction, whatever I apply to the forward draft,
Minus.
initially this is my initial drafts. I applied the rise. I will apply the rise equally. I will subtract it and get the drafts after applying the sinkage or rise. Then in this case, since I am discharging from the forward section and it is from forward of the LCF, my forward draft will reduce. So I will subtract from forward and add in the forward, add in the aft section. Okay, so my final drafts will be this. Okay, understood on this?
Yes, sir.
Yes, sir.
Okay. So there's nothing much. First thing what you have to see is, first thing, as soon as you read the problem, you have to see whether you're discharging or loading. So whether you're loading or discharging, then you will come to the conclusion whether the vessel is going to, you have to find out the sinkage or you have to find out the rise. Okay, so once you have done that, then you have to see, actually find out the change of trim. Now for finding out the change of trim, you need to know the value of D. Now finding out the value of D, you have to draw a sketch. Okay, once you draw a sketch only, you can assess where the position of D is. Now what is the position of the D? How will you define it?
From forward, from F to from 88 to 118, sir.
No, okay, fine. With respect to this, it is 88 to 1, but in general, it is from the LCF position to the position.
Forward, sir.
Yeah,
Okay.
it is from the LCF position to the position where the weight is being loaded or discharged. Okay, so just remember in that way, from the LCF position to the point where the weight is being loaded or discharged. So that will be your small d value. So then once you find out that small d value, you can get on with your finding out the change of trim. So you found out your change of trim. With that, you can get the corrections forward and aft. Now you got the corrections, but you need to assess the forward and aft corrections whether to be added or subtracted to each drafts. For that, you have to again see what operation you have done. You have discharged, and wherever you discharge, you have discharged it from forward of LCF. You have to see whether it is forward or aft with respect to LCF. So since in this case you have discharged forward of LCF, your forward draft will decrease. So accordingly, you will add your or subtract your corrections to each drafts and get your final drafts. Okay, so if you get this basics right, then as we go in, it will be easier for you. So understood on these two topics where
Yes, sir.
fine. Okay. Slowly, what we are doing is initially we started off with change of trim. Then we started off with LCF positions. Then we saw LCF when it is a midship, how it affects the trim. When it is not a midship, how it affects the trim. So till that time, we were doing only shifting of weights, either from forward to aft or aft to forward. Now slowly what we are doing, we are actually going into effect of when you're loading a weight or discharging a weight. When you're loading or discharging, what is happening to the trim of the vessel. Okay. So now we have seen up to here single weights, right? Now effect of loading and discharging of weights, but these are all single weights, only one weight which is either loaded or discharged. Okay, next we will see multiple weights.
Multiple ways.
Okay, so when you're doing a problem with multiple weights, of course you will have a tabular approach. Now, have you done a moments table in your previous semester?
Yes, sir.
Yes, sir.
Which table? What you did?
KG, finding KG, sir.
Finding
I'm
KG.
finding the list also using moment table.
Okay, fine. You were using the moments table. So this is something similar to that only. We will be doing it, and we will see how it is something similar to that only. Moments you will be taking because you're not loading one single weight, and there are multiple weights, and some weights are loaded, some weights are discharged. Now let's say a ship of length 120 meters in length floats at a draft of forward 6.24 and aft 6.36. LCF is given to you 54 meters FOAP. TPC is given to you and MCTC is given to you. Now these are the following operations which are done. You have loaded 120 tons. Okay, LCG of that cargo. Normally for each individual weights, when I say that for a particular cargo, it is LCG means gravity longitudinal LCG of that particular weight is 10 meters FOAP. The second weight is 68 tons loaded, LCG is 86. Next two operations are discharge, and the LCG values are given. With this, we have to find out the final drafts. Okay, so what we will do, let's first initially draw a sketch. Okay, what is the ship's length? It is 120 meters. Whenever ship's length is given, it is actually LBP only. So my LBP is 120. If my LBP is 120, this is my midship. So my midship will be around 60.
60.
Okay. My midship will be around 60. LCF is given to me as 54. So where will it be? 54
Aft of midship. Aft of midship.
Aft of midship.
Okay, very good. So my F position is somewhere here. It is at 54. Okay. So now what I will do, we will go into a tabular column, and let's take the first column. First column, what we will do, we will just see what and all weights we have loaded and discharged. Whatever we have loaded, we will put a positive sign, or we'll just keep it 120. First was loaded, second was loaded, third one was discharged, 36 tons, and fourth one was also discharged. So 36 and 48. So when we get it, the final value will be 104 loaded. Okay, because you add these both weights and you're going to subtract these discharging weights. But final, your effective weight is 104 loaded because we have loaded more cargo. So that will be your first column. The second column, what you will do, you will do the weights because we will be taking a moments. So we need to see how the moments works. So my first one is I have loaded 120 tons weight. Now the second column will be distance from LCF. The same thing how we did in a single weight problem. What we did from the LCF, what was the distance? We did it. Here also the same thing we'll be doing, but for multiple weights. So first let's take the first weight 120. What is the distance from LCF? Let's take the LCG of that first weight. What is LCG given? 10 meters FOAP. 10 meters FOAP means 10 meters forward of half perpendicular. It is so somewhere here, my first weight. This is 10 meters. So what will be my distance from LCF?
54 minus 44. Sir.
Yeah, that is from F value to this point. Okay, my F value is at 54 and I have loaded a weight at 10 meters FOAP. So my distance from LCF will be from 54 to 10, so which is 44. Okay, so this will be my distance from LCF of the first weight. So now let's take a second weight. This is my midship and this is my LCF at 54. Okay, and my sorry.
One doubt, sir.
Yeah, tell me.
Sir, LCG full form, sir.
Sorry.
It mentioned no LCG 10 meter FOAP. That means
FOAP means forward of aft perpendicular.
yes, sir. That I know, sir. Before that LCG.
LCG, longitudinal center of gravity.
Okay, sir.
LCG, you have studied LCG and LCB, right? Longitudinal center of gravity and longitudinal center of buoyancy.
Yes, sir.
Okay, LCG is something like for that weight. Okay, supposing I have loaded a weight here. Anywhere you load a weight. Where did we go about that LCG and LCB? Fine. G is the longitudinal center of gravity and LCB. G, whatever weight you load anywhere in the vessel, there will be LCG value is something like from the aft perpendicular, how much distance it is being loaded. From the aft perpendicular, what is the distance at where it is being loaded for that weight, center of gravity of that weight from aft perpendicular. From aft perpendicular to the center of gravity of that weight is the distance LCG for that particular weight. And when you loaded that weight, what will be your LCB? That will differ. Okay, so that is LCG. Normally for each weight, you will be given an LCG where it is being exactly loaded because you know where at what point it is loaded, right? So that is denoted by LCG. Understood?
Yes, sir.
Okay, fine. So now the next thing is LCG, longitudinal center of gravity, is 86 meters FOAP. So 86 meters means where it will come? It will come somewhere here.
Forward of midship.
Forward of midship, 86 meters. This is where I have loaded the second cargo. Now tell me what is the
32. 32, sir.
32, sir. We have to minus 86 minus 52.
Yeah, no, don't. Okay, fine. From F to this point, from F to point where it is loaded. So it will be 86 minus 54. That will give you me 32. Okay, so these two were loaded. Now the third thing we will see, discharge 36 tons. LCG is 22 meters FOAP. So where it will come, 22 meters, somewhere here. Okay, so now what will be the distance from LCF?
24.
30.
32, sir. No, sir. Yes, sir.
Okay, good. 32.
Yes, sir.
Fine. Okay.
Yes, sir.
Fine. It is actually from 54 to 22. This difference here. Okay. Earlier it was from 54 to 86. Now it is from 54 to 22. So that will give me 32. Okay. So that will be my third distance. Now fourth distance is discharge 48 tons, LCG 60 meters FOAP. So 60 meters FOAP is
Forward of midship, sir.
Midship.
6 meters, sir.
Yeah, midship. Exactly. Good. So it is exactly at midship. So what is the distance?
6 meters.
60 minus 50.
6, sir.
60 minus 54, 6, sir.
Yeah, 60 minus 54. It is exactly this distance because you are not loaded at midship. Your F is somewhere after midship. So this distance from F to, we have actually loaded at midship, but my F is somewhere here. So this distance will give me 6 meters. Okay. So now you understand how to get the distances.
Yes, sir.
Sir.
Yes, sir.
Yes,
We
sir.
did it for single weights. For multiple weights, we will be each drawing and assessing where it is. Okay. So you need to be very accurate in this. If you make a mistake here, then your entire calculation will go wrong. Okay. So now you found out the distances. Now we need to find out the moments. So for the moments, what we will do, we will keep one as head moments and one as turn moments. So how we will decide this is, whenever you load anything, so this is my midship and my F is somewhere here. So in this case, if I load anything, just remember, if you load anything forward of F, because I already told you F is your pivot point. F is my pivot point. So if I load, let's say it is not at midship. If F is here, anything if I load forward of F will have a head moments. Anything I load aft of F will have a stern moment. Okay, so F position is the pivot point, which I've already told you. So anything you loading forward or aft will change accordingly. So if you're loading something forward, you will have a head moments, and loading aft, you'll have a stern moments. Okay. So we will be taking the same concept here. The first one, 120 meters, LCF, we got it. So 120 into 44 will give me my moments, 5280. So why have I put it in the stern moments column? Because where are we loading? The first,
Aft, sir.
yeah, the first one, 120 tons, we are loading at 10 meters. That is, we are loading somewhere here. So it is aft of F. So we will have a stern moment. The second one, again 68 into 32. Let's see, where are we loading? We are loading 86 meters FOAP. So that is, we are loading somewhere forward of F, right? 86.
Yes, sir.
So this will give me a head moment because my F is here at 54. So I have included this in the head column. Now next is discharging. LCG is 22 meters FOAP.
8 stun. 8 moments, sir.
So again,
Reverse.
it is aft of LCF. Okay, but here in this case, I am not loading, I am discharging. Though the position of the weight is aft of LCF, I am discharging the weight. So if I'm discharging, obviously you will have a head movement. So that is why I have put it as head movement. So you need to see whether it is forward or aft of LCF. First thing. Second thing, you have to make sure whether you're loading or discharging. So accordingly, place the movements. Otherwise, if you make a mistake, because straight away if you say, okay, fine, this is aft of midship, it will be a stern movement. So it will go wrong. So always you have to see the position whether it is forward or aft and what operation, whether loading or discharging. So since here it is discharging, it will be a head movement. The last one, LCG 60 meters FOAP. So where it will be? Head or stern?
Stern, sir.
Stern, because
Load in the app.
no man, discharging man.
Discharging.
Discharge in the app, sir.
Discharging 48 tons at 60 meters FOAP means at midship only you are discharging. But where is this point? It is forward of F, right?
Yes, sir. Yes, sir.
It is forward of F and you're discharging. So obviously you'll have a stern moment. So that is why I put it in stern moment. So always remember, don't get confused. First you have to see at which position, whether it is forward or aft of LCF. Then you have to assess whether it is loading or discharging. These two criteria you have to assess. Then only you can exactly put where is your head movement and stern movement. Okay. So once we get the head movements, we will add here. We will get the stern movements here. Subtract it. And what will be the final moments?
Which is greater? The starboard is greater. Stern is greater, sir.
Stern is greater. So this will be actually 2240 by stern moments only. Same thing what we applied here. Since we are loading, so finally we got that it will be 104 meters loading and we got the stern moments. Okay. So now what we do, we will do the same method how we did before, calculating the sinkage of the vessel. Why sinkage? Because here loading is
Stern
more,
movements.
not because of stern moments. Here we have loaded. Okay, loading has come more here. So sinkage will be W by TPC. W we have already found out 104. So
Sir,
100.
if it will be negative means discharging, right? Means rise.
Sorry.
If it will be in the negative, like 104 came in a positive answer. So we are sinkage. If it will come in negative means discharging, right? Rise.
Yes, it will come in the discharging part. So that is
Okay,
why
sir.
you need to be, because 120 plus 68 minus this value. Here we got the positive value. So it is loading of weights. Supposing we get a negative value, means discharging is more. So then we will name it as rise. Okay.
Yes, sir.
So it will be 104 by 14.2, which will give me my sinkage of the vessel. Okay. So next I will be calculating the change of trim formula. Now, if you remember change of trim formula, initially it was trimming moments by MCTC. Remember this? It was change of trim was trimming moment by MCTC. But we rearranged it and introduced W into T because we were doing single weights. So when we are doing multiple weights, we will be using moments. Trimming moment by MCTC. So we know our trimming moments, it is 2240. Okay. And here also, if the trimming movements is by the head direction, is by the other direction, you will get a negative value. But don't you can write it here as negative, but don't put here as negative and all and get the answer negative trim. So don't use plus and minus here. If you get a negative, you take it, you write it, put the negative sign and write down that the vessel is going by head. Okay, don't put negative signs in this change of trim and all. You have to write it down. So you get the final value here. I have written down as by stern. So if you get a negative value here, you will write it as 19.3 centimeters by head. So just write head or stern. Don't write positive or negative values. Fine. So we got our change of trim. So then we will be using the trim aft formula. What is the formula for trim aft?
A by LBP into COT.
Yeah, A by LBP into COT. And for forward, it is F by LBP into COT. So what is A in this?
LCF.
LCF.
54.
LCF value is given as 54. So it will be A will be equal to LCF. So 54 by 120 into 19.3 will give 0.087. Okay. So now in this, you can do a slight improvisation. You can either use this formula TF is equal to F by COT, F by LBP into COT, or you can say that I already got the aft correction. I know my change of trim. So if I subtracted this from this, I will get the remaining correction, right? So you can do this also. Trim forward is equal to change of trim minus trim aft. Or you can use that formula also, not a problem. But this will be much faster. So I will get the remaining correction, 10.6 centimeters. Okay. So now I know my initial drafts. I know my sinkage, which is 7.3. I will add that sinkage. I will get the sinkage drafts. Now, whether I have to subtract or add the correction values, forward and aft?
Sir,
Adding, sir, because loading.
Adding, loading. Yes.
no, after you have to add.
Yeah. When you tell me, just tell me precisely. Aft you have to add and?
In the forward minus, sir.
Yeah, exactly. Because the final trimming moments, what we got is by stern. So when we get the final trimming moments by stern, my aft draft will increase and my forward draft will decrease. So I will add the aft correction and subtract the forward correction. Okay, understood on this? Any doubts in this? Multiple weights?
No, sir.
No, sir. No, sir.
Fine. Okay, good. So it's nothing much complicated. You have to just get yourself accustomed to where is the LCF position and where are the weights being loaded. Once you get that clarity, then you need to see the head movements and stern movements. There you have to be little more careful because you need to see where it is being loaded, where the position of the weight is and loaded or discharged. Okay, so accordingly you get your weight and movements.
Sir,
Yeah, tell me.
sir, what if the load is exactly loaded on pivot point, sir, in F, sir?
What if?
The load, like 80 tons load is loaded on exactly at pivot F point, LCF.
I already discussed that, right? When you're loading exactly at F, fine, let me tell you.
I didn't come.
Yeah, okay, fine. Let me take a picture where F is aft of midship. Fine, here. So in previous problems, we, shifting of weights, we were doing this. So now what happens? Now F is actually aft of midship. Okay, well, what we did when F was at midship? When F was at midship, we had only bodily sinkage, right?
Yes,
Okay.
sir.
Now what happens? Though F is aft of midship, but if I load exactly at F, you will have only bodily sinkage. You will not have a trim effect. Means, let's say you have an initial draft forward 4 meters and my aft draft is 5 meters. Sorry. Okay. And I am loading exactly at F position. So in
Sir,
this
both
case,
will increase, sir.
yeah, only my bodily sinkage will be there. I won't be having anything trimming because when will my vessel trim? This is my pivot point. My vessel will trim only when I am loading aft or forward of LCF, right? Otherwise, my vessel
Sir.
will not trim.
Yes, sir. Understood, sir.
Okay, fine. So that is why when you load a cargo exactly at LCF position, your vessel will have only bodily sinkage. So you will find out only sinkage and add it to the both forward and aft drafts. You won't be doing the trim correction. Trim corrections you will be only applying when you're loading anything aft or forward of LCF. Okay.
Okay, sir.
Okay. I guess I will stop with this and